What if I told you that right now, in this very moment, you might be living inside a computer simulation? That everything you see, touch, and experience is nothing more than code running on some unimaginably advanced machine. Before you click away, thinking this is just science fiction nonsense, consider this. Some of the world's most brilliant physicists and philosophers are taking this idea seriously. Very seriously. And the evidence they've uncovered is absolutely mind-blowing. By the end of this video, you're going to question everything you thought you knew about reality. So buckle up, because we're about to go deep down the rabbit hole. Before we get started, check out the link in the description to download our ebook. All right, let's start with the basics. What exactly is simulation theory? Simply put, it's the hypothesis that our entire universe, everything we call reality, might actually be an artificial simulation. Think of it like a video game, but infinitely more sophisticated. Just like characters in The Sims don't know they're in a game, we might be digital beings living in a simulation without realizing it. Now, this isn't just random speculation. The idea gained serious traction in 2003 when philosopher Nick Bostrom published his infamous simulation argument. He proposed that at least one of three things must be true. Either civilizations go extinct before they can create realistic simulations, or advanced civilizations have no interest in creating simulations of their ancestors, or we are almost certainly living in a simulation right now. Think about it. If it's possible to create conscious simulations, and if any civilization eventually develops this technology, they could run millions or even billions of simulated universes, which means there would be far more simulated realities than base realities. Statistically speaking, you're more likely to be in one of the many simulations than in the one original reality. But statistics aside, what actual evidence suggests our universe might be simulated? Let's dive into the mind-blowing stuff. Here's where things get seriously strange. Quantum mechanics, the science of the very small, behaves in ways that eerily resemble a computer simulation trying to save processing power. You know how in video games, the environment only fully renders when you're looking at it? The rest remains as basic code to save memory. Well, quantum particles seem to do the same thing. They exist in multiple states simultaneously, a phenomenon called superposition. But the moment you observe them, they collapse into a single definite state. It's as if reality only bothers to render the details when someone's watching. Then there's quantum entanglement, what Einstein called spooky action at a distance. Two particles can be connected in such a way that measuring one instantly affects the other, no matter how far apart they are. This shouldn't be possible in a purely physical universe bound by the speed of light. But in a simulation, it makes perfect sense. The particles aren't really separated by space. They're just data points in the same system connected through the underlying code. And here's the kicker. There's a fundamental limit to how precisely we can measure certain pairs of properties simultaneously. It's called the Heisenberg uncertainty principle. In a simulated reality, this would be exactly what you'd expect. There's only so much information the system can process at once, so it sets a resolution limit. Sound familiar? Here's something that's puzzled scientists for centuries. Why is the universe so perfectly mathematical? And I mean perfectly. Every single physical law, from gravity to electromagnetism, can be described with stunning precision using mathematics. The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics. Think about it. Mathematics is something we invented as a tool, yet it describes reality with perfect accuracy. How is that possible unless reality itself is fundamentally mathematical? Unless perhaps reality is literally made of math, made of code. Look at the Fibonacci sequence. It appears in flower petals, spiral galaxies, hurricanes, even the proportions of the human body. Pi shows up everywhere, from the way rivers curve to the behavior of quantum particles. These mathematical patterns repeat at every scale of existence, from subatomic particles to galaxy superclusters. If you were programming a universe, you'd use mathematical rules and algorithms to generate complexity from simple laws. You'd create patterns that scale and repeat, which is exactly what we see. Our universe runs on elegant equations that compress enormous amounts of information into simple formulas. That's not just poetic. That's exactly how you'd efficiently code a reality. The speed of light, 299,792,458 meters per second, isn't just fast. It's the ultimate cosmic speed limit. Nothing can go faster. But why? In a physical universe, there's no obvious reason for this hard cap, but in a simulated universe, it makes total sense. Think of the speed of light as the universe's refresh rate, the maximum speed at which information can propagate through the system. Every simulation has processing limits. In our computers, we call it bandwidth or clock speed. In the universe, we call it the speed of light. And here's something even weirder. Time itself dilates as you approach light speed. Move faster through space, and time slows down for you relative to everything else. This is Einstein's relativity, and it's been proven countless times. But think about what this means in computational terms. The simulation can't process everything at maximum speed simultaneously, so it adjusts the flow of time to keep everything synchronized. It's literally frame rate adjustment at a cosmic scale. Even stranger, there's a limit to how much information can be contained in any given region of space. It's called the Bekenstein bound, and it suggests the universe has a maximum information density. Again, this is exactly what you'd expect from a simulation running on finite computational resources. Now, this is where it gets really wild. At the smallest possible scale, reality appears to be pixelated, not smooth and continuous, but chunky and discrete. There's a fundamental size limit in physics called the Planck length. It's unimaginably tiny, about 1.6 times 10 to the negative 35 meters. Below this scale, the concept of distance itself breaks down. You literally cannot have anything smaller. It's the universe's pixel size, the smallest unit of space that can exist. The same is true for time. There's a Planck time, the smallest possible duration of time that has any meaning. Reality doesn't flow smoothly. It progresses in tiny discrete jumps, frame by frame, just like a computer rendering a simulation at an incomprehensibly fast frame rate. Even energy comes in discrete packets called quanta. That's literally where quantum mechanics gets its name. Everything in the universe is fundamentally granular, made of indivisible units. The universe has a resolution limit, just like your computer screen is made of pixels or your digital photo is made of individual bits of data. In a truly physical, continuous universe, you should be able to zoom in infinitely. But you can't. There's a hard limit. Almost as if you've reached the base layer of code, the fundamental grid on which reality is computed. This one's a real head-scratcher. The fundamental constants of the universe, things like the strength of gravity, the mass of electrons, the cosmological constant, they're all fine-tuned to an absurd degree of precision. Change any of them by even a tiny fraction, and the universe collapses, or atoms can't form, or stars can't ignite. Life becomes impossible. Reality itself becomes impossible. The odds of all these constants randomly landing in the narrow range that allows for a stable, life-bearing universe are astronomically small. We're talking 1 in trillions upon trillions. So why is our universe so perfectly calibrated? One explanation: it's not random. It's designed, programmed. Someone or something set the parameters deliberately. They adjusted the cosmic dials to specific values that would produce a stable, interesting universe. Just like a game designer tweaking variables to make their game world function properly. And get this, when physicists run computer simulations of universe formation, they have to input these exact constants manually. They're essentially programming baby universes with carefully chosen parameters. Which raises the obvious question, is someone doing the same thing one level up? Here's where simulation theory gets deeply philosophical. The observer effect in quantum mechanics shows that the act of measurement changes the outcome. Reality literally behaves differently when it's being observed versus when it's not. Experiments like the double-slit experiment demonstrate this perfectly. Send a particle through 2 slits without observing which slit it goes through, and it behaves like a wave, creating an interference pattern. But observe which slit it passes through, and suddenly it behaves like a particle, creating 2 distinct bands. The particle's behavior changes based solely on whether it's being watched. This suggests that consciousness, or at least observation, plays a fundamental role in shaping reality. In a simulated universe, this makes perfect sense. The simulation only needs to compute the full details when there's an observer present. It's computational efficiency. Why render what no one's experiencing? Some physicists go further, suggesting that consciousness itself might be the whole point of the simulation. Maybe we're not just in a simulation. Maybe we are the simulation. Our subjective experiences might be the actual purpose, the reason the whole thing is running in the first place. Now, if we're in a simulation, you'd expect occasional glitches, right? Moments where the code breaks down or produces unexpected results. And guess what? We find them. Take the Mandela effect, where large groups of people remember events or details differently from how they actually occurred. Now, false memories are real and well documented. But the Mandela effect often involves thousands of people sharing the same specific false memory. It's as if a variable was changed in the code, and some cached memories didn't update properly. Then there are déjà vu experiences, that uncanny feeling that you've lived through an exact moment before. What if that's a glitch? A loop in the code? A moment that got processed twice? Even weirder are quantum computers. When we build quantum computers, we're essentially exploiting the probabilistic nature of quantum mechanics to perform calculations. But think about what that means. We're using the rules of our potentially simulated reality to build computers within that reality. It's recursion, simulations within simulations, and quantum computers work because they tap into quantum superposition, which, as we discussed, already behaves like a computational shortcut. Let's play with this idea for a moment. Imagine you're a character in The Sims. You have thoughts, feelings, experiences, but you're made of code. Now, here's the question. Does it matter? If your experiences feel real to you, if you have consciousness and emotions, does it change anything that you're simulated? Or think about this. If our universe is a simulation, who created it? And are they also in a simulation? Could there be an infinite stack of simulated realities, turtles all the way down? Or is there a base reality somewhere, the original, unsimulated universe? And if so, what's it like? Here's an even more unsettling thought. What if the simulation can be paused or rewound? What if it's been shut down and restarted multiple times, and we'd never know? Every time it starts up again, our memories would be part of the initial conditions. You could have lived this day 1,000 times before, and you'd have no way of knowing. And if we're in a simulation, could we ever prove it definitively? Or would any attempt to detect the simulation be prevented by the very rules of the simulation itself? It's like asking a character in a video game to understand they're in a game. They might gather evidence, notice patterns, but they're still bound by the game's code. So, what would it actually mean if the universe is a simulation? Let's think through the implications, because they're profound. First, it would mean there's something beyond our universe. Creators, programmers, whatever you want to call them. They would be, for all practical purposes, gods. Beings with the power to create and destroy entire realities. This doesn't necessarily conflict with religious beliefs, by the way. It just adds another layer. Maybe God is the ultimate programmer. Second, it would suggest that consciousness is substrate independent. If we're simulated beings with real experiences, then consciousness isn't dependent on biological brains. It can arise from any sufficiently complex information processing system. This has huge implications for artificial intelligence. Could we create conscious AI? Are we already simulated AI? Third, it opens up the possibility that death isn't the end. If we're code, we could potentially be backed up, transferred, or even restored. Maybe death is just the end of this particular instantiation of your consciousness pattern. But here's the flip side. If we're in a simulation, it could be turned off at any moment. The entire universe, everyone you've ever loved, every thought you've ever had, could vanish instantly. And not just vanish, cease to have ever existed at all. Does that terrify you? Or does it make you appreciate this moment, right now, even more? So, is the universe a simulation? Honestly, we don't know. We might never know. The evidence we've explored today is compelling, even unsettling, but it's not proof. It's patterns, coincidences, and deeply strange behaviors at the edges of physics that happen to fit the simulation hypothesis remarkably well. But here's what I think is the most important takeaway. Whether we're in a simulation or not, the implications for how we live our lives might be exactly the same. Your experiences are real to you. Your relationships matter. Your choices have consequences. The beauty you perceive, the love you feel, the struggles you face, they're all genuine from your perspective. Maybe the question isn't whether we're in a simulation. Maybe the question is, if we are, does it change anything? Does the universe become less majestic because it's computational rather than physical? Does your life become less meaningful because it's coded rather than concrete? Or maybe, just maybe, discovering that we're in a simulation would be the ultimate liberation. it would mean we're part of something impossibly larger than ourselves. It would mean consciousness is eternal, transferable, perhaps even unlimited. It would mean reality is far stranger and more wonderful than we ever imagined. So I'll leave you with this. Whether we're flesh and blood in a physical universe, or patterns of information in an inconceivably vast computation, we're here, we're thinking, we're experiencing. And isn't that, in itself, the most mind-blowing thing of all? What do you think? Are we living in a simulation? Drop your thoughts in the comments below. And if you enjoyed diving into this existential rabbit hole with me, hit that like button and subscribe for more deep dives into the nature of reality. Because if we are in a simulation, we might as well try to understand the code. Thanks for watching. And remember, whether you're real or simulated, you matter.